Today I'll show you how to model a steel stud wall in THERM and get the U factor and surface temperatures, and I'll be doing this using the keyboard shortcuts for drawing from a dimensioned drawing rather than using a DXF underlay. The wall we will be modeling will have plaster on the outside, 7/8 inch thick plaster. It'll have 3.5 inch of fiberglass insulation with steel studs in it that are 0.05 inches thick, and then it will have 5/8 of drywall on the inside, and the studs will be 16 inches on center. And what I'm going to start doing is creating the materials for plaster, fiberglass, and the drywall in THERM. The steel is already in the material library, but these other products aren't. So I'm going to fire up THERM. I'm using THERM 6.3, but you could do the same thing in THERM 5. And I'm going to go into the library, material library, and create a new material. I'm going to call plaster. And the conductivity that I have is 0.277. And the emissivity of 0.9 is fine. I'm going to pick a color. Let's pick something like this on the outside. And I'm going to make a next material, which is going to be the fiberglass insulation, and it will have a conductivity of 0.023, emissivity of 0.9, and let's pick a different color for that. Let's pick a green for that. And now I'm going to make the drywall material. And all these connectivities I looked up on the internet. They are readily available for whatever material you're using. And this one's 0.15. And let's pick a crazy purple color for that one. So I've made all these, and now I'm going to start drawing my cross section. So I'm going to use the dimension drawing method, and I'm going to start with drawing a rectangle. The studs are 16 inches on center, and I'm going to model two studs with a little bit of spacing above and below them. So I'm going to actually model 32 inches. So let's go ahead and do that. Here I'm going to draw a rectangle, and I'm just going to click somewhere near the bottom of the screen. It doesn't really matter where. And I'm actually not going to click, I'm just going to press enter, which sets the beginning of the rectangle. And now this is the plaster, so it's going to be 32 inches tall. So all I do, I don't touch the mouse anymore. I've hit enter to start my rectangle. I just start typing 3.2, and you see this step size box comes up, and I press up arrow. And you see in this case we're actually off the screen, but that's fine. So that's at the height of the rectangle, and it's 7/8 inches thick. So I'm just going to start typing 0.875, and you see the little step size box comes up, and then without clicking anywhere or doing anything else, I'm just going to hit the right arrow. And you see it steps over a size, and I'm going to press enter, and that finishes my rectangle. So now if I do control right click, it zooms the complete drawing, and I see I have my material here, and I actually want to change this from drywall to plaster, because this is the outside. So here's the plaster one. And now I know that I have a 3.5 inch gap, and then I have my drywall on the inside, so I'm going to draw that. And I'm going to click again here on draw rectangle. And now I'm going to put my cursor close to this corner, somewhere close to it. And I'm going to just type I didn't click, I'm just going to type 3.5, right arrow. And that just stepped my cursor over 3.5 inches. Now I'm going to press enter to start drawing, and now again I type 32, up arrow to set the step size. I stepped up 32 inches, and the inside drywall layer is 5/8, so I'm going to type 0.625, right arrow, and I'm going to enter to define the second corner of my rectangle. So I defined the lower left hand corner and the upper right hand corner. Go ahead and enter, and yes, the material here is drywall. So now I've drawn the two layers, and I'm going to go and draw the steel studs. I'm going to draw one stud roughly here and one stud here. And what I'm going to do for that, I'm going to zoom in a little bit in. Let's see if that's too much. Maybe I'll zoom like this much. Back to the original scale. And now I'm going to actually draw a polygon, not just a rectangle. I click draw polygon, and I'm going to go to this lower corner, and I know that my steel U-channel stud is going to start 7¼ inches up. So I'm going to type 7.25 up arrow. That sets the beginning position. I'm going to press enter. And now I'm going to draw all the side segments of my U-channel polygon. So I started drawing. I know it's 1.5 inches tall, so I'm going to go 1.5 up arrow, enter. It's 0.05 thick, so I type 0.05 right arrow, enter. I know that I need to go down 1.45 inches, enter. Then I need to go to the other side. There's two wall thicknesses of 0.05, so instead of going 3.5, I'm going to go 3.4 inches over, enter. Then I need to go 1.45 inches up again, enter. 0.05 inches over, enter. 1.5 inches down, enter. 3.5 inches left, enter. Let me zoom in here, and you see here we have the stud. So I start in this corner, I went up 1.5 over 0.05, down 1.45, right, minus this thickness here, the 0.05, get to this corner, then I went over 1.4 inches, so 3.4, so instead of 3.5, which is total width on each side, I have 0.05, so I go 3.4 over, then 1.45 up, 0.05 over, 1.5 inches down, 1.5 inches, and then 3.5 inches here, and I close the polygon. Now you see the material actually shows up as drywall because I didn't set it before, so I can go in here and just change that to steel. Let's see, rolled ground steel. So there's our first steel stud, and I'm going to draw the next one, and that's going to be 8 inches up there, or sorry, there's 16 inches on center. So I'm going to let's go to this corner here, and we're going to go up. I'll start the drawing mode, and this time let me pick the material while we get started. So steel, and I'm going to go to this corner, and I'm just going to be close to that corner, and now I'm going to type 16 up arrow, and that's off the screen. That's not so great. Let's do it. Let's zoom out a little bit more. Let me just actually draw the U-channel on a different, more zoomed-in view here, so you can see what it looks like. So what I did earlier: 1.5 up, 0.05 over, 1.45 down, and 3.4 over, 1.45 up, enter. 0.05 over, enter, 1.5 down, enter, and 3.5 inches. Oh, sorry, 3.5. Okay, so I'm going to go back to my corner here, and then say 3.5 to the left. I didn't draw that correctly. Actually, I can also just go here and just click and it'll close it. So now I have I've drawn it separately here, and I'll go paste it in. So what I'm going to do, you get to see the locator feature here as well. I'm going to go draw locator. I'm going to set the locator in this lower left-hand corner, and you see a little circle. And I'm going to go over in the other drawing and set the locator where I want to paste it. So I know that's going to be 16 inches up from this corner. So I'm going to go here near this corner. Actually, I can zoom in and do it off screen. So we're near the corner here, and I'm gonna just do type 16 up arrow, and then I'm gonna do F2, which is draw locator. Accept. Let's see if that did it. It started drawing. So see, there's draw locator here, which is Shift F2, and I hit the wrong key. So let's try that again. Go to this corner here. Get close to this corner here. And it's okay if it's off the screen. So now here, and I'm going to go 16 inches up, and I'm doing Shift F2, Enter. So what that should have done is set the locator. See, there it is. So this is the one stud, and this is the location for the next stud. Now if I go back to the stud I just drew here, if I select it, say Edit Copy, it's going to copy it and it's going to reference it to that locator position. I'm going to go here and just say Paste, and it will paste it right at that location. You see that where the lower left hand corner matched up, except I didn't get my locator quite in the right place, so it's overlapping here now. This will happen occasionally. So it looks like when I pick the locator position, I'm going to delete this, I need to be actually right over here. So let's put the locator right on the edge there. And function F2. And it's going to eyeball it here that it's going to be on the material. And now let's paste it again. That looks better. So now it's in the right location. So now that I have the two studs in the drawing, I'm going to fill it up with insulation. And the way I can do that is the lower one here, I can, the middle one actually, let's do that first. I'm going to pick the fill paint bucket, and I'm going to pick fiberglass insulation. And I'm just going to click in here, and it's just going to fill that whole area up with fiberglass insulation. And now at the lower part here, what I will do is I'm just going to draw a dummy rectangle just to close this off. And now I can use again this fill bucket in here, and it fills this whole area. Now I'm just going to delete this, and I'm going to do the same at the top. So what we do is we block off the opening with the dummy, and we click fill, and it fills in here. We could of course draw the insulation in here, but we'd have to go and notch out the steel stud, which would be a little bit of work. So I'm going to save this now, and I'm going to call it steel stud example. And now we get to generate the boundary conditions, and most likely there will be some slight overlapping points because the way I copy and pasted things, objects in. So I'm going to click BC, and let's see, it seems like it worked fine. I have a boundary condition here on the outside and here on the inside. I'm going to pick this one here and press enter, and I'm going to use in this case the NFRC exterior boundary condition, which is 32 degrees Fahrenheit. Actually should be 0 Fahrenheit. I guess it got changed in here. And it's 4.58 BTUs. 32 Fahrenheit, that's interesting. Let's just verify that when we double click on it. Okay, there was a little display problem there because we're doing a screen recording, but it's really 0 Fahrenheit, 0.4. And then we're going to click here on the inside, and what I'm going to use here is actually the NFRC interior wood vinyl frame convection only coefficient. You should of course always figure out what the correct film coefficient for your application is. In this case I'm using this one, which is 0.43 BTUs of convection, and then we're doing automatic radiation. You can read about this in the simulation manual. So I'm going to click OK, and now I'm ready to calculate this file. I don't have any U factor tags yet, so let's actually go here and call this a U factor. Let's actually make a new U factor, and we'll call it wall. You could call it anything, but it just is nice to have a meaningful name. So I'm going to click wall and click OK. And now I'm going to calculate the file. And what I see is, in the results here, I see the isotherm. So I see that the temperature drops here where the steel stud is a thermal short circuit. I can see the U factor of this wall is 0.14, and I can also have some other view options. If I go to display options, I can show, for example, the color infrared, which is a color mapping, and you can see this, and you can see how the surface temperatures are changing. And I can also, if I go back to display options, I can say show the polygon outline over it and show color legend. And now you can actually see the steel stud here, and you can see the temperatures. So you see that right here, the temperature is about 52, where in the most other areas it's much closer to 65. The other view I can do is the color flux magnitude, and that shows me where the most flux is going through the cross-section. And of course, no surprise, where there's a steel stud, we have a lot of heat flux going through it. So this shows how the heat flux spreads out and concentrates on the thermal bridge. So this is good for thermal bridge analysis, and this is the mesh that we can see that the program automatically generates. That's more just informational. So there you have it in a nutshell, how to create a steel stud wall and calculate a U factor for it and look at the surface temperatures of it. Thank you very much. This is Christian Kohler for the THERM 6.3 demo for wall simulations.